Hello everyone, in this video we'll be solving problem 134 gas station. The problem statement is there are a total of n gas stations along a circular route where the amount of gas at ith station is gas of I. We have a car with unlimited gas tank and it cost of I gas to travel from ith station to I plus 1. We need to return the gas station's index if we can travel around the circuit once in the clockwise direction, otherwise return minus 1. It was difficult for me to understand the problem statement just by reading. I had to draw it on the paper to get a better idea. So let's switch to whiteboard and discuss the problem statement better. I will try to solve example number 1. Let's begin with plotting all of the gas stations and the distance on a circuit. The values in blue are the index of the corresponding element. Values in red represents the amount of gas available and the values in green represents the amount of gas needed to reach the next destination. Let's start with station number 1, that is index 0. With an empty tank and only 1 unit of gas available, we won't be able to get to the next station because we need a total of 3 units of gas. As we don't have a surplus of gas available, there's no point in starting from station number 1, as the difference between the supply and demand is minus 2. Similarly, let's check on station number 2 if we can start the journey from there. The amount of gas available is 2 and we need a total of 4 gas units to reach to the next destination. As the demand is still higher, we won't be able to start the journey from station 2 either. We are in a similar situation with the next station 3 as well, where the amount of gas available is 3 and we need a total of 5 units of gas. So we can't start our journey from this point either. Next station is 4. The amount of gas available is 4 units and we need a total of 1 unit to reach the next station. So as the supply is higher than the demand, with an empty tank, we can start the journey from station 4 and reach station 5. And once we reach station 5, we'll be left with 3 units of gas in the gas tank. At gas station 5, there is 5 units of gas available, so which will be added to the gas tank, totaling up to 8. And we need 2 units to reach to the next station. So we have enough surplus of gas available to make that journey. When the car reaches station number 1, it will have 6 units of gas available. It should be enough to go to the remaining stations in the circuit and complete the loop. As we started the journey from station number 4, its corresponding index is 3, which will be our output. I hope at a high level you got an idea how this problem can be solved. Now let's work on building an algorithm around it. As we are starting with a car with no gas in the tank, we need to make sure that the amount of gas available across all gas stations is greater than or equal to the amount of gas needed to cover the circuit. Let's say we have a total amount of gas as 10 and we need 12 units to complete the circuit. There is no way we can complete the entire circuit, whichever station we choose to start the journey from. One way to solve this problem using brute force is to iterate through all of the elements in the given array, setting it to the starting point of the journey and see if we can complete the entire circuit. That is, the difference should be positive and we should be able to get to the next station. If we can complete the entire circuit, then we return the starting point's index or else increment the pointer and try a different combination. With this solution, the time complexity will be O of n square as we are trying to complete the circuit at different starting points, which will require running nested loops. While the space complexity will be O of 1 as we are going to be using couple of pointers to point at the starting index and the amount of gas available to make the journey. Now let's try to tweak the solution so that we can improve our time complexity. Another way to solve this problem is to use the greedy algorithm, where we can use the diff between the two arrays to avoid running nested loops. During the loop, if we encounter any entry whose difference is negative, we can't start the journey from that position because we won't be able to get to the next station, so we can ignore those completely. The first positive difference is at gas station 4, which is 3. We can consider that as the starting index. As I mentioned earlier, this is only possible because the total amount of gas available is equal to the total amount of gas needed to complete the circuit. Now we can start the calculation to record the amount of gas remaining after making the journey from I is equal to 3 all the way till the end. If at any iteration the difference between the gas available and the gas needed goes below 0, it means we can't complete the circuit, so we need to change the starting index. At gas station 4, we have a surplus of 3 units of gas available. Considering it as a starting point, we move on to the next station, which is gas station 5. Over there, the amount of surplus is 3 and the 3 was carried over from the previous transaction, so we are left with a total of 6 units of gas in the car tank. Normally, when we are at the end of the loop and we want to see if we can complete the entire circuit, we would reset I is equal to 0 and cover all of the elements to the left hand side of gas station 4. It is not needed because we know that the total amount of gas available across all of the gas stations is equals to the gas needed. So we can go with the assumption that if we ended with a positive number at the end, we will be able to complete the loop. Let's try a different example where we have a positive difference at the start of the array. First element in the gas array is 4, so the difference is going to be 1, which is positive. The remaining difference are the same. Going by the earlier logic, if the difference is positive, it can be considered as the starting index for the journey. So we can start the journey at I is equal to 0 or gas station 1. When we reach the next station, to reach station number 3, we have a total of 3 units of gas available, but we need 4. So as we are running short, we won't be able to reach gas station 3. This means that there are no gas stations to the left hand side of the current gas station where we can start the journey from. So we'll try to focus on the starting index that should be on the right hand side of the current index. That is, reset the available gas to 0 and increment the pointer to the next element to see if we can start this journey from there. We will continue to repeat the same cycle until we figure out the valid starting point. With this solution, our time complexity is O of n, as we are running a single loop to calculate the difference between the gas available and the gas needed, while the space complexity is O of 1, as we are only using a couple of variables to record the starting point and the amount of gas available. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by checking if the amount of gas available is greater than or equal to the amount of cost needed to complete the entire circuit. We return -1 if the condition is not met. Inside the if condition, I am initializing a couple of variables. The return value will hold the index of the starting point. The total will hold the total amount of gas available, and then starting a for loop. Inside the for loop, I calculate the difference between the gas and the cost and add up to the total. If the total is negative, it means we can't go any further. So I'm resetting the total to 0 and incrementing or setting the return value to I plus 1 so that we can start a new loop. If the condition is not suffice, which means the total is greater than 0, we continue with the existing values which was configured in the previous runs. Once the for loop is complete, we return the return value variable as the output. This code, when submitted on LeetCode, beats nearly 30% of the submissions in terms of runtime and 9% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.